Assalamu alaikum everyone. Myself Mohammad Shahriar Mannan Prutta and my ID digits are 024 222 Today we are here to give a presentation on our course Computer Architecture and Organization. Our presentation topic is data path. Before starting, I would like to introduce my team who are also going to give presentation with me today. They are Mahtab Chaudhary, Redwan Rahman, Mohyuddin Shorob and Azimullah Tamim. So let's delve into the fascinating world of datapath. If we talk about datapath, the first topic came in our mind is multiplication. Multiplications are of two types, combinational multiplication and sequential multiplication. Combinational multiplication directly calculates the product using logic gates. They are fast but require significant hardware. On the other hand, sequential multiplications use a series of steps to calculate the product. They are slower but require less hardware. We can talk about Booth's algorithm, a popular sequential multiplier that simplifies the multiplication process by using a combination of addition and subtraction. So let's compare these two multipliers. If we talk about speed, then the combinational multiplier is faster than the sequential multiplier. In case of hardware use, combinational multiplier use high-level hardware and sequential multipliers use low-level hardware. Combinational multiplier consume more power than the sequential multiplier. In case of use, the combinational multiplier has high-speed system. On the other hand, sequential has low-power embedded system. Design is complex in combinational multiplier, but on the other hand, in the case of sequential multiplier, the design is very simple. Let's talk about the advantages of multiplexers. Efficiency. Multiplication allows for the rapid calculation of repeated addition, saving time and effort. Number 2. Foundation for higher math. Multiplication is a fundamental to understanding more complex mathematical concepts like algebra, geometry, and calculus. Real-world application. Multiplication is used in various real-world scenarios such as calculating cost, measuring distance, and solving problems in science and engineering. Practicing multiplication can improve mental math abilities, making it easier to solve problems quickly and accurately. Multiplication is a key tool for problem solving as it allows for breaking down complex problems into smaller, more manageable steps. Pattern recognition. Multiplication can help identify patterns and relationships between numbers, aiding in logical thinking and reasoning. Every light has its opposite dark side. Similarly, multiplication has some disadvantages. Let's talk about it. Number 1. Complexity. Multiplication can become complex, especially when dealing with larger numbers or multiple digit operation. Error prone. Human error can easily creep into multiplication calculations, leading to incorrect results. Number 3. Time consuming. For large number, multiplication can be time consuming, especially when done manually. Number 4. Extensive multiplication can lead to mental fatigue, reducing focus and accuracy. Last but not the least, dependency on basic skills. Multiplication relies on strong foundational skills in addition and subtraction. So any weakness in these areas can hinder multiplication performance. That's all from me. Now I would like to call my teammate Azimullah Tamim for continuing the slides. Thank you.
Assalamu alaikum. My name is Azim Ullah Tamim and the four digit of my ID number are 1705. At first, thanks to my friend Shariar Mannan Prattoy to call me to give a presentation about this topic. So, division, combinational and sequential. Combinational division, direct calculation using logic gate, high hardware cost but offers fast performance. Sequential division, iterative approach using a series of subtractions or comparisons. lower hardware cost but slower performance. Restoring division, a common sequential division technique that involves restoring the dividend after is subtraction. Then combinational division, a combinational circuit that directly produces the quotient and remainder from the input dividend and divisor. Characteristics: fast operation, complex hardware implementation, and area intensive. Applications: high performance processors, digital signal processing, example a simple 4-bit combinational divider. Then sequential division, a sequential circuit that performs division in multiple clock cycles using a series of subtractions and shift. Characteristics: slower operation, simpler hardware implementation, and area efficient. Applications: microcontrollers and embedded systems. Then non-restoring sequential division flowchart. Explanation of the flowchart is: initialization, number of bits in the dividend, means n, and equal to dividend initially set to 0, and m is the divisor. Shift left aq, shift the a and q registers left by 1 bit. Subtract divisor, subtract the divisor from a, sac sign of a. If the sign of a is negative, that means set the least significant bit of q to 0, restore a by adding m back to it. If the sign of a is positive, set the least significant bit of q to 1. Decrement n. Decrement n by 1. Check n. If n is not equal to 0, go back to step 2. If n is equal to 0, the quotient is register q and the remainder is in the register a. Explanation of the flowchart. It is the restoring sequential division flowchart. Initialization. In there, n means number of bits in the dividend, and a means dividend, and the m means divisor. Shift left aq, shift the a and q registers left by 1 bit. Subtract divisor, subtract the divisor m from a. Check sign of a. If the sign of a is negative, set the least significant bit of q to 0. Restore a adding by m back to it. If the sign of a is positive, set the least significant bit of q to 1. Decrement n. Decrement n by 1. Check n. If n is not equal to 0, go back to step 2. If n is equal to 0, the quotient is in register q and the remainder is in register a. So that my presentation is done. Then I want to call my another friend Mathab Chaudhary to give description about the presentation. Assalamu alaikum everyone.
Azimullah Tabim. Salam alaikum sir. Myself Mahatab Chaudhary. My ID last four digit are 1076. Today I am talking about pipelining. What is pipelining? Pipelining is a technique used in computer architecture to improve the performance of a processor by dividing the instruction execution process into smaller and independent stages. This allows multiple instructions to be processed rather than sequentially. Types of pipelining. Instruction pipelining. This is the most common type of pipelining where the execution of instruction is divided into multiple stages. Arithmetic pipelining. Here, arithmetic operations like addition, subtraction, multiplication, and division are divided into a smaller stage. Functional unit pipelining. This involves pipelining the execution unit within a processor such as ALU and FPU. Now, pipelining processing. Instruction phase. Phase the next instruction from memory. Second instruction decode. Decode the instruction to determine the operation and operand. Calculate operand. Determine the address or value need to. Phase operand. Actual data or operand from memory or register. Execute instruction. Perform the instruction a specific operation like arithmetic, logic operation, or jumping to a new program location. Write back. Write the result of the operation back to the operand register. Here is the
Two stages of instruction pipelining. Now, advantages of pipelining: increase through output. By overlapping the execution steps of multiple instruction, pipelining allows the processor to execute more an instruction per clock cycle, increase overall performance, improve performance. Pipelining reduce the effective execution time of instruction, leading to faster program execution, enhance efficiency. By keeping the processor's components busy, pipelining improve resource utilization and reduction idle time. Now, disadvantages of pipelining: increased hardware complexity. Pipelining require additional hardware components such as register and control logic to manage the pipelining stage. This can increase the cost of size of the processor. Clock cycle limitation. The clock cycle period must be long enough to the longest pipeline stage, which can limit the overall clock speed. Pipeline hazard. Different types of hazards such as structural data and control can dispute the smooth flow of instruction through the pipeline and reduce performance. Instruction dependency. If instruction depends on the result of previous instruction, the pipeline may stall and reduce performance. Last but not the least, increased power consumed. The additional hardware and increased clock frequency associated with the pipelining can lead to increased power consumption. Now I would like to call Redwan Rahman to continue further discussion. Thank you for your valuable attention.
Assalamu alaikum. Thank you, Mahatab Chaudhary. Now I will talk about arithmetic logic unit. So there are three parts of arithmetic logic units. First is core data part. An arithmetic logic unit performs arithmetic and logical operations on data input, formatting the core of data path. Operations. Arithmetic logic unit operations include addition, subtraction, multiplication, and divisions, also AND, OR, XOR, NOR, and more. Control signals. Arithmetic logic operations are controlled by signals that select the specific operation to be performed. Now, design of a simple arithmetic logic unit. Define operations. It determines the set of operations to be supported by the arithmetic logic unit. Choose logic gates. It selects the appropriate logic gates to implement the desired operations. Next is control logic. It designs the control signals to select the specific operations to be performed. And last one is test optimize. It truly tests the designed arithmetic logic unit and optimizes its performance. Now design of a one bit of arithmetic logic unit. Arithmetic logic unit can be designed as an adder that can conditionally perform other functions based on the selection of control inputs. Arithmetic logic unit is designed as a chain of identical one-bit adder which may not be efficient for large numbers of bits. And the adder functions are sum and cout. Thank you everyone. Now I would like to call Mohiuddin Shorab to explain the next slides. Thank you.
Thank you, Ridwan Rahman, for giving me opportunity. Assalamu alaikum. Myself, Mohiddin Shorab. My ID last four digit is 1075. Now I am talking about the topic of coprocessor. Coprocessor has three types. First of all, specialized tasks. Coprocessor handle specific tasks like floating point calculations, graphic processing, or digital signal processing. And second is performance boost. By offloading specialized tasks, processors can significantly improve the overall performance of a system. And then integration. Processors are integrated into a system to work alongside the main processor, extending its capabilities. And then conclusion and key takeaways. Combinational operations. Fast but require high hardware costed. Sequential operation, slower but less hardware. Arithmetic logic operation is core component for arithmetic and logic operations. Coprocessor. Enhance performance by offloading specialized tasks. Pipelines. Increases throughput by dividing instruction processing into a stage. Thank you. If you have any question, you can ask in your comment section. We will try to reach back to you.